National Electrical Code 314.29 states that electrical equipment shall not be installed within 3 feet of a private dwelling's septic tank, cesspool, or other source of gases or vapors that constitutes a potential hazard to persons or property. This 3-foot rule applies to all electrical equipment, including subpanels. The rule is intended to prevent the accumulation of hazardous gases or vapors near electrical equipment, which can lead to explosions or electrical fires. If a subpanel is mounted within 3 feet of a septic cleanout, which is a potential source of such gases or vapors, the installation violates the National Electrical Code. Possible solutions include the following. Firstly, relocate the subpanel. Move the subpanel to a location that is at least 3 feet away from the septic cleanout. Secondly, install a gas-tight barrier. Install a gas-tight barrier between the subpanel and the septic cleanout to prevent the accumulation of gases or vapors. This could be a sheet of metal or a specialized gas barrier material. Thirdly, install a gas detector. Install a gas detector near the subpanel to alert occupants if hazardous gases or vapors are present. Fourthly, cap and seal the septic cleanout. Ensure that the septic cleanout is properly capped and sealed to minimize the release of gases or vapors. It is recommended to consult with a qualified electrician to determine the best solution for any specific situation. The electrician can assess the risks and recommend the most appropriate and code-compliant approach. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA. Adherence to the National Electrical Code is crucial to ensure the safety of people and property. Several factors are considered when determining the safe distance between electrical equipment and potential sources of hazardous gases or vapors. These include the type of gas or vapor, the concentration of the gas or vapor, and the type of electrical equipment. If the electrical equipment is not properly rated for use in a hazardous environment, it could ignite the gas or vapor and cause an explosion or fire. The 3-foot rule is a general guideline, and in some cases a greater distance may be required. For example, if the gas or vapor is highly flammable, a greater distance may be necessary. If there are concerns about the safety of an electrical installation, it is important to consult with a qualified electrician or other expert. They can assess the risks and recommend the most appropriate safety measures. Gas-tight barriers are typically constructed of materials that are impermeable to gases and vapors. Common materials include metal, plastic, and rubber. The barrier should be properly sealed to prevent gases or vapors from escaping. Gas detectors are electronic devices that detect the presence of gases or vapors in the air. They can be used to monitor the air near electrical equipment to ensure that hazardous gases or vapors are not accumulating. Gas detectors are typically equipped with an alarm that will sound if a hazardous gas or vapor is detected. In addition to the National Electrical Code requirements, there may be local codes or regulations that apply. It is important to check with the local authorities to ensure that all applicable codes and regulations are followed. The purpose of the National Electrical Code is to protect people and property from electrical hazards. By following the National Electrical Code, electrical systems can be installed and maintained in a safe and reliable manner. When relocating a subpanel, consider the following factors. Firstly, the new location must be accessible for maintenance and repairs. Secondly, a new location must be protected from physical damage. Thirdly, the new location must be dry and well ventilated. Fourthly, the new location must meet all applicable National Electrical Code requirements. When installing a gas-tight barrier, be sure to seal all openings and seams to prevent gases or vapors from escaping. The barrier should be made of a material that is compatible with the gases or vapors that may be present. When installing a gas detector, follow the manufacturer's instructions. The detector should be located in an area where gases or vapors are likely to accumulate. The detector should be tested regularly to ensure that it is working properly. When capping and sealing a septic cleanout, use a cap that is designed for that purpose. The cap should be properly sealed to prevent gases or vapors from escaping. Regularly inspect the cap to ensure that it is in good condition. In addition to the above measures, It is important to practice good housekeeping in areas where electrical equipment is located near potential sources of hazardous gases or vapors. Keep the area clean and free of clutter. Do not store flammable materials in the area. Ensure that the area is well ventilated. By following these safety precautions, the risk of explosions and fires can be minimized. Electrical safety is everyone's responsibility. Be aware of the hazards and take steps to protect yourself and others. If ever in doubt, consult with a qualified electrician or other expert. The electrician will check to see that the working space is adequate to work on the electrical equipment. The electrician will also make sure that the equipment is properly grounded. Grounding is a safety measure that helps to protect people from electrical shock. The electrician will also make sure that the equipment is properly labeled. Labeling helps to identify the equipment in its function. The electrician will also make sure that the equipment is properly maintained. Regular maintenance can help to prevent electrical hazards. Some signs of electrical hazards include the following: firstly, flickering lights. Secondly, sparking outlets. Thirdly, warm or hot outlets. Fourthly, burning smells. If any of these signs are present, immediately turn off the power to the affected circuit and consult with a qualified electrician. Remember that electricity can be dangerous. Always take precautions to protect yourself and others from electrical hazards. The National Electrical Code provides detailed requirements for electrical installations. It is important to consult the National Electrical Code to ensure that all electrical work is performed safely and correctly. The National Electrical Code is available from the National Fire Protection Association. The National Fire Protection Association website is a valuable resource for information about electrical safety. The website contains information about the National Electrical Code, electrical safety tips, and other resources. Electrical safety training is available from a variety of sources. Consider taking an electrical safety training course to learn more about electrical hazards and how to prevent them. Electrical safety is an important topic that everyone should be aware of. By learning about electrical hazards and how to prevent them, lives can be saved and injuries can be prevented. Always be careful when working with electricity. Never take chances. If ever in doubt, consult with a qualified electrician. The NEC mandates specific clearances around electrical panels to ensure safe operation and maintenance. These clearances include working space in front of the panel, headroom, and side clearances. Working space should be at least 3 feet deep, 30 inches wide, and 6 feet 6 inches high. Headroom should be at least 6 feet 6 inches high. Side clearances may vary depending on the voltage of the equipment. These clearances are designed to provide enough space for electricians to safely work on the equipment. The NEC also requires that electrical panels be properly labeled. The label should identify the circuits that are controlled by each breaker. This helps to prevent accidental electrical shocks. The NEC also requires that electrical panels be properly grounded. Grounding helps to protect people from electrical shock by providing a path for electricity to flow safely to the ground in the event of a fault. The NEC also includes requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current. These devices will trip or blow when the current exceeds a safe level, interrupting the flow of electricity and preventing damage to the wiring and equipment. The NEC also includes requirements for wiring methods. Wiring methods refer to the types of wiring that are allowed to be used in different applications. The NEC specifies the types of wiring that are suitable for use in dry locations, wet locations, and hazardous locations. The NEC also includes requirements for the installation of electrical equipment. The NEC specifies the proper methods for installing electrical equipment, such as lighting fixtures, receptacles, and appliances. The NEC also includes requirements for the inspection and testing of electrical systems. Regular inspection and testing of electrical systems can help to identify potential problems before they cause a fire or other hazard. The NEC is a living document that is constantly being updated to reflect new technologies and safety concerns. It is important to stay up to date on the latest requirements of the NEC to ensure that electrical systems are installed and maintained safely. The NEC is a complex document, but it is essential for ensuring electrical safety. By following the requirements of the NEC, electrical systems can be installed and maintained in a safe and reliable manner. It is recommended to consult with a qualified electrician or electrical engineer for assistance with interpreting and applying the NEC. They can provide guidance on the specific requirements that apply to the installation and ensure that the work is performed in accordance with all applicable codes and regulations. The NEC also addresses the use of arc fault circuit interrupters, or FSIs. FSIs are designed to protect against fires caused by arc faults, which are dangerous electrical conditions that can occur when damaged or deteriorated wiring creates an unintended electrical arc. FSIs are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. The NEC also addresses the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock by detecting ground faults, which occur when electricity flows through an unintended path to the ground. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The NEC also includes requirements for surge protection. Surge protection devices are designed to protect electrical equipment from damage caused by voltage surges, which are sudden increases in voltage that can damage or destroy electronic devices. Surge protection is recommended for sensitive electronic equipment, such as computers, televisions, and appliances. The NEC also addresses the use of smoke detectors. Smoke detectors are required in all homes to provide early warning of a fire. The NEC specifies the location and installation requirements for smoke detectors. The NEC also addresses the use of carbon monoxide detectors. Carbon monoxide detectors are required in homes that have fuel-burning appliances, such as furnaces, water heaters, and fireplaces. Carbon monoxide detectors provide early warning of carbon monoxide poisoning, which can be deadly. The NEC is a comprehensive set of standards that addresses all aspects of electrical safety. By following the requirements of the NEC, homes and businesses can be protected from electrical hazards. The National Electrical Code is a crucial resource for electricians, contractors, and homeowners. It provides the guidelines necessary to ensure that electrical systems are installed and maintained safely, reducing the risk of electrical fires, shocks, and other hazards. The NEC is not just a set of rules, but a comprehensive system of safety measures developed and refined over many years by experts in the field. It takes into account the various factors that can contribute to electrical hazards, such as faulty wiring, overloaded circuits, and improper grounding. Compliance with the NEC is not just a matter of following regulations, but a commitment to protecting lives and property. It requires a thorough understanding of electrical principles, proper installation techniques, and ongoing maintenance practices. The NEC is constantly evolving to keep pace with technological advancements and emerging safety concerns. It is regularly updated to incorporate new research, address new hazards, and improve existing safety measures. Staying current with the latest edition of the NEC is essential for anyone involved in electrical work. The NEC is not a one-size-fits-all document. It contains provisions that are tailored to specific types of electrical systems, occupancies, and environments. For example, there are separate requirements for residential, commercial, and industrial installations. There are also specific requirements for hazardous locations, such as areas where flammable gases or vapors are present. The NEC is a complex document, but it is well organized and clearly written. It is divided into chapters, articles, and sections, each addressing a specific aspect of electrical safety. The NEC also includes numerous tables, diagrams, and examples to help clarify the requirements. The NEC is not a substitute for professional expertise. It is intended to be used by qualified electricians and other professionals who have the knowledge and experience necessary to interpret and apply the requirements correctly. Homeowners should always consult with a qualified electrician before undertaking any electrical work. The NEC is a valuable resource for anyone who wants to learn more about electrical safety. It provides a wealth of information on electrical principles, installation techniques, and safety practices. The NEC is also a useful tool for identifying and correcting electrical hazards. By following the recommendations in the NEC, electrical systems can be made safer and more reliable. The NEC is a testament to the importance of electrical safety. It is a reminder that electricity is a powerful force that must be treated with respect. By taking the necessary precautions, the risks associated with electricity can be minimized and the benefits can be enjoyed safely. Always remember to prioritize safety when working with electricity. If you are not comfortable with any aspect of the work, consult with a qualified electrician. Do not take chances that could put yourself or others at risk. The National Electrical Code is a living document that is constantly being revised and updated to reflect the latest advances in electrical technology and safety practices. It is essential for anyone working in the electrical industry to stay current with the latest edition of the NEC. By adhering to the standards and guidelines outlined in the NEC, electrical professionals can ensure the safety and reliability of electrical systems, protecting people and property from the hazards of electricity. The NEC is not just a set of rules, it is a framework for ensuring electrical safety. It provides a comprehensive system of standards and practices that cover all aspects of electrical installations, from the design and selection of materials to the installation, testing, and maintenance of electrical equipment. The NEC is a valuable resource for electricians, contractors, inspectors, and homeowners. It provides the information they need to make informed decisions about electrical safety. The NEC is also a valuable tool for training and education. It provides a framework for teaching electrical safety principles and practices. The NEC is a dynamic document that is constantly evolving to meet the changing needs of the electrical industry. It is essential for anyone working in the electrical industry to stay current with the latest edition of the NEC. By adhering to the standards and guidelines outlined in the NEC, electrical professionals can ensure the safety and reliability of electrical systems, protecting people and property from the hazards of electricity.